In this section of 7.1, we're going to solve the triangle using the law of sines. If it can't be used, we need to state why and also draw a triangle before we begin to get a picture of what's going on. So we're going to do number 15 for our example. So I'll start by drawing a triangle. I'll just draw it kind of randomly. I guess I don't really want it to look like an equilateral, so I don't know. So there's my triangle, and let's get some, just kind of randomly pick A, B, C. Side A is across from angle A, side B is across from angle B, and side C is across from angle C. Okay, so it says that B is 60 degrees, and A is 30 degrees, and side B is 10 radical 3. And I'm asked to use law of sines. So to use the law of sines, let's see, the ratio I have is the b's. So I have sine of b is to side b as sine of, let's see, the other angle, the other information I have is the angle A. So I'll use that. And I don't know side A, but I'll find it using this. So I get sine of B is 60 degrees. Side B is 10 radical 3. Sine of A and side A. Do some cross multiplication. Sine of 30 degrees times 10 radical 3 equals A times sine of 60. And I get that A equals 10 radical 3 sine of 30 over sine of 60. Now, since 30 and 60 are special angles, I can use my unit circle to find that sine of 30 is actually 1/2. And sine of 60 is radical 3 over 2. I'm going to put my A over here just because I like A on the left. And that can be simplified. So half of 10 gives me 5 radical 3 divided by radical 3 over 2. So that's flip the second and multiply. And my radical 3's will cancel. And I'm left with 5 times 2, which is 10. So let's see, I'm solving the whole triangle, so I'll go ahead and make a table here with my sides and my angles. And I have side equals A equals 10. I have side B equals 10 radical 3. I have angle A equals 30, angle B equals 60. This is a side angle triangle. So I got one side, and now I can also get that third angle by using the triangle sum. So I got 180 degrees minus 60 degrees and minus 30 degrees, leaves me with 90 degrees. And to get that third side, I will use law of sines again. So I'm just going to shrink up that to make some space for myself. So my last side is side C, so I need a ratio with C in it. So that gives me sine of C, angle C is over side C. I have all this information right now, so I really could use either sine of A over A or sine of B over B just to set up a proportion. I'll just use the same one I used for the first part and set that equal to sine. Actually, you know what? I'm going to do the sine of 30 because I like how it gives me that 1/2 and I don't have any radicals. So sine of 30, okay, so that's sine of A is to A which we just found as 10. Actually, I'm going to write this, what I'm doing, a little better. So I'm going to do sine of A is to A, as to side A, as sine of C is to C. And I have A, angle A is 30, side A is 10, sine of C is 90, and C is, side C is the one I'm going to solve for. Now I know sine of 30 is 1/2 divided by 10 equals sine of 90. Think about your unit circle. When you're at 90 degrees, that y value is 1. So this is 1 over C. And then cross multiply. And I could have cross multiplied before I did this part. It doesn't matter. But that's what I get. And then I get C equals, multiply both sides by 2 to get C by itself. And I get 20. So now I have a 20 here. Turns out this is actually a right angle, and you can see my triangle's not drawn to scale. A is 10. And as a quick check, I can recognize that this is a 30-60 triangle. So looking at those ratios, the hypotenuse is twice as long as the shortest side, which is what I know about 30-60-90 triangles. So that is my final answer. Oops, you know what? It's not my final answer because I also need units. So I need to add some inches.